Previous, you can stop screening our slide and let Dr. Bala to present his slides.
Okay, sir.
Sir, can you start presenting your slide?
Mohan, is this better?
Yeah, it is audible.
Still not good?
Maybe your voice is very mild.
I see. I will try to speak a little louder.
Okay, okay.
Can you hear me?
Yeah, it's okay. It's fine. It's fine. So you can start presenting your slide.
Yeah. If you are not able to hear me, let me know.
Okay, okay, fine. It's fine. So you can present your slides.
All right. I'll just.
So you can present your slides.
Yeah, I'm just going to. Can you see them? Are the slides visible now?
We can see.
Yes?
Yeah. You can present your slides. Visible, visible. Okay. Okay.
Okay. I will start the presentation.
No, wait, sir. Wait, sir. Wait for a few minutes. Yes. We'll introduce you, then you can start speaking.
Okay, please go ahead.
Yeah. Okay. So slide is missing.
Yeah, I'm just going to present it again. Okay. Meanwhile, why don't you go ahead and start introducing?
Okay. Okay, PBS, you can start.
Okay, sir. Good evening, participants. IEEE CS Madras, ACM Chennai, and CSA Chennai chapters cordially invite you to a webinar on supply chain management and the smart factory strategies by Dr. Parasuram Balasubramanian, founder and CEO, Teamwork Analytics Private Limited, Bangalore. Smart factories are the future of supply chain resilience. The COVID pandemic has triggered fundamental changes that will continue to accelerate innovation. Supply chain leaders can boost organization resilience by adopting the smart factory, an innovative holistic solution that enhances supply chain capabilities through the use of artificial intelligence, IoT, and robotics. Dr. Parasuram surveys the landscape to identify the likely changes in the supply chain arena due to current and impending technologies. The shop floor and the warehouse are getting transformed into smart factory with the introduction of IIoT drones and autonomous vehicles at a fast pace in the developed economies. Developing countries, however, are under twin pressures of adopting these productivity and safety measures versus providing employment protection to millions of workers. Hence, it's a challenge for Indian firms to make appropriate technology choice. Dr. Parasuram will explain how to build a framework for modeling the supply chain and the factory in the Indian context and identify a country-specific strategy for adoption of digitalization technologies. Dr. Parasuram Balasubramanian, fondly known as Bala, has been a consultant, group leader, CIO, CEO, and profit center head in information technology industry in his career spanning 4 decades. He has played a noteworthy role in establishing analytics practice in India and established India as a premier offshore service destination. He was instrumental in introducing high technology quality standards for software delivery services and in building the skill sets of thousands of employees. He has worked in India, Jamaica, and USA. Over the years, Dr. Bala has sustained considerable interest in academics and executive training. He has been a guest faculty and invited speaker in numerous colleges, executive training programs, and industry fora. He has written chapters in Handbook of Operation Search, CRC Press, Handbook of Automation, Elsevier Publishers, and in Cultural Factors in System Design, Decision Making and Action, CRC Press. He is a member of the Enterprise Integration Consortium at Penn State University, USA, Board of Studies at RBCE and MSRIT in Bangalore and CIT in Coimbatore. Dr. Bala has engineering and management degrees from IIT Madras and a doctorate from the School of Industrial Engineering at Purdue University in 1977, specializing in operation research. He has been recognized as an outstanding industrial engineering alumnus by Purdue University in March 2001, fellow at Infosys Technologies Limited in 2002, and made an honorary fellow of the Indian Institute of Materials Management in 2005. He was an honorary entrepreneur in residence at Purdue University, Discovery Park from 2006 to 2011. Over to Dr. Parasuram. Thank you.
Thank you, Mr. Subramanian. Can everyone see the slide? Is it visible to you?
Yes, we can.
Yes?
Yes.
Okay, I'll start. Thank you, gentlemen. Good evening and Happy New Year to every one of you. It's wonderful to spend the next 1 hour on a very important topic from many angles. And I will start the presentation on supply chain management and the smart factory strategies by looking at a video to start with, which will give us the current state of the art in terms of application of these technologies to a real world situation. And also it points out to where the future lies. So we'll start with this video presentation, which is the short 1-minute video. This is from the Purdue University campus in United States of India. The gentleman you see is the president of the university, Mr. Mitch Daniels. Is ordering his lunch. And there is this Starship delivery robo, which is going to deliver the food to him. It is now traveling at a speed of about 6 kilometers per hour through the university campus. and reaches the building where the president works. He's coming down the stairs. There is an interactive voice recognition technology. So the food is safely delivered to the right person after authenticating his identity, and the delivery robo is now ready to move on to the next location. What we saw in that video tells you where the technologies have come together. It is not just one technology, it is multiple digital technologies such as voice recognition, autonomous vehicle, delivery robo, machine vision, artificial intelligence. Many of these have come together to make this delivery possible. But I also mentioned that it also talks about, it will highlight what issues are there for the future. For example, you may have noticed that the vehicle had to be seen or met at the end of the stairs. Obviously, it has no capability to climb stairs. Even worse, it can only go up to the beginning or entrance to a building. From there to go through the walkway and reach the front door of a house, it has to be trained yet. Even more importantly, you saw it traveling the walkways along with the students. If the walkways are crowded, then the delivery vehicle struggles to accommodate with them, taking care of itself as well as the safety of the students. So there are still some bugs to be ironed out, but already 30 odd vehicles are in work in Purdue University campus and in 4 other universities. At the end of this year, they would like to try out about 5,000 of them in various other universities so that it becomes fully debugged and foolproof. So given this status, now let us delve deep into the subject that we have. What are digital supply chains and smart factories? What technologies are underneath these applications driving them? What is the level of maturity of these technologies? And are there any business imperatives for us to rush and accept them and adopt them, particularly in the Indian context? If so, is there a pick and choose? Is there a prioritization that we can adopt in terms of factory, product, services, and logistics? And how do we build all the required skills sets in the process? This is essentially what we plan to cover during the next 40 minutes or so. Supply chain constitutes material flow within the factory environment, purchase, stores, production, warehousing, and delivery to the customer. All of those activities take place within the premises of a factory, but supply chain also extends beyond the factory environment. It encompasses the front end linkages with the vendors, as well as the back end linkages with distributors, retailers, all the way to the customer. In other words, we can see it is an end-to-end coordination of all the suppliers with the manufacturer and all the way to the customer. The complete chain constitutes supply chain, and it calls for coordination, cost control, agility, and resilience management. The key factor to note here is that the material flows from one end all the way to the other end, and every step of the way value addition takes place. So it's the flow of the material with value being added stage by stage that constitutes the fundamental aspect of the supply chain. You can also note that as the money flows, as the material flows, money also has to flow within the network. From one party to the other, funds have to be transferred for all the activities to take place. Material flow and money flow need to be synchronized, coordinated with the flow of information. So when we talk of a supply chain, really we are concerned with flow of materials, flow of money, and flow of information. In a way, we can also say that activities that take place within the factory environment need to be subject to the value addition, best value addition check. If for any reason, any one of those activities where value is added is not commercially competitive, meaning somebody else, a third party, can provide that service better and cheaper than what the factory itself can do, it makes a strong case for buy rather than make. So the make or buy decision that we constantly encounter in a supply chain has to be answered by who is in a position to add the best value to the network. We have been studying supply chains for almost 50, 60 years now, both in the industry and academia. And it has been well understood that what drives the entire network is the procurement and delivery of products and services. If you look at the products in a typical retail shop, there is a model called capital S, small s. The capital S defines the high end of the inventory they wish to hold. The small s defines the low end, meaning if the inventory they hold drops below the small s level, a reorder is placed, and when the order comes, the inventory level goes up, and then over the next period, inventory is depleted until it crosses the small s line, and hence the replenishment policy depends on capital S and small s. But in the process, managing supply chains, we have learned many concepts and many lessons, out of which 3 stand out. First and foremost is the concept that anywhere in the system, holding inventory is unwanted, because only when the goods and services are provided to the customer, money is realized. Otherwise, idly sitting inventory, whether it is finished goods or work in process or raw materials, is not adding value. Instead, it is only adding to the cost. So the notion that inventory is evil has come about. And in the process, the inventory is evil. If so, the best way to avoid holding inventory is to shift from make to stock to make to order. In other words, a committed customer who is also making a payment in advance, they come under this make to order category. It's far better than mass production, holding it in stock and waiting for a customer to come and buy it. So the first lesson that we have learned is to move from make to stock to make to order as much as possible in any manufacturing production situation. The second one is known as the bullwhip effect. We saw that there are end customers, there are retailers, there are distributors, and there are manufacturers. But all of them don't see the end demand pattern the same way. Everyone's demand is seen in terms of orders being placed on themselves. So the variations in demand at one end get exacerbated as it moves up the supply chain. This is called bullwhip effect. In other words, even a nominal variation in demand pattern at the customer end magnifies itself and seen to be a very large variation in the eyes of the manufacturer. This bullwhip effect can be, and its impact can be minimized only when information about the demand, product demand, is shared across the network by all the partners. This is the second most important lesson that we have learned. The third one is the relationship between tier 1 supplier to tier 2 supplier to tier 1 to manufacturer, manufacturer to distributor. What kind of a business professional relationship should they have? Should it be a tightly coupled relationship or loosely coupled or a flexible one? It has been time and again found that a flexible coupling strategy is far better in the interest of all the players. A tight coupling implies that the vendor or the supplier is very tightly married with the interest of the manufacturer, which means all the risks, all the vagaries of demand faced by one are fully transmitted to the other. On the contrary, with a flexible coupling, multiple vendors can be contracted with by a manufacturer and vice versa. So both parties have the option of reaching out to multiple customers in the marketplace. So we have already found that these three concepts work better in the supply chain. You will now see that every one of the digital technologies that has been introduced plays a vital role in facilitating each of these three goals. In a way, we can say in the last 50 years, supply chains have moved from being production-centric to first market-centric, meaning what is being produced is focused on the market and market demand. Hence, products are getting segmented. Product features are customized to the market requirements. And this is how the first revolution has taken place in the supply chain, moving all production, all activities from production-centric to market-centric. Now, in the last 20 years, with the introduction of internet and widespread direct link with customers, end customers, it is also moving from being market-centric to customer-centric. The make-to-order scenario helps us to make this transition very well. If you, for example, notice what Dell did even a few decades ago was to go directly to the customer, take his order, and then manufacture the product to the customer's requirement at the factory, and in the process receive all funds in advance, and every computer that was built in a Dell factory was already committed to a specific customer and also meeting the customer's specific demands. If many other products can also be made to move from being market-centric to customer-centric, it would mean considerable efficiency in the supply chain, and digital technologies have come to play a very significant role in making this happen. Along with internet and widespread use of related technologies, an added phenomenon has come to play. This is globalization. Globalization of products, services, and investments, all of that have meant that markets worldwide are accessible to a player in manufacturer in any country, and they are now in a position to reach out to them, to the customers, and provide goods and services. However, the customers have also become very, very demanding in the process. Every delivery has to be customized, and it has to be authenticated and preferably anonymous. Anytime, anywhere delivery is being demanded these days. No longer limited to the 9 to 6, 10 to 6 kind of time limitations. And no longer you need to go and pick it up in a particular store, brick and mortar store. In other words, wherever you are, whatever time that customer requires the item to be, one need to be geared to provide it. From the seller's point of view, non-repudiated delivery and safe deliveries also are added requirements. So these have become added considerations to the supply chain, and you will see that the digital technologies are very well geared to deliver on this requirement of the customer. Yet another concern that has come up due to globalization is the heightened concern for environment and conservation of all the resources that we have in the world. This is a factor to contend with. No longer customers, citizens, and people at large are satisfied with what we call a linear supply chain, meaning raw materials are utilized to produce parts. Parts are used in manufacturing. The final product is served to the customer. And once the customer has utilized the product fully, then it goes to a landfill or a recycling center. This used to be the linear mode in which products were delivered and utilized in many of the countries. This is no longer acceptable. After use, products have to be, one has to recycle the product as much as possible in multiple ways. For example, a product that only some components are not functioning well need to be refurbished. It goes back to the factory, the defective parts are set right or replaced, and the product is once again tested and delivered back to the marketplace. Or appropriate parts are harvested from it, and these parts are utilized in next set of generation of goods that are being produced. In the least case, we should at least be able to take out some of the raw materials or components and recycle them into the system. In other words, rework, refurbishing, and recovery, all of them have become part of fundamental objectives of supply chains. What are the business imperatives for taking this road? You will find that India's logistics cost is about 14% of the GDP. It is far higher than the global average of 8%, meaning our goods and services are not competitive enough to be successfully offloaded in the global market. In fact, a study has estimated, excuse me, I'll have to reload it again. Can you see it? Hello?
Yes, yes. Yes,
Okay,
sir.
We
we're
can
able
see,
to-
we can
we're
see.
able to see it. Okay. So oh gosh. Bear with me for a few minutes. Yeah. the competitive of what goods and services we have provided to the world market is estimated as $180 billion. In other words, over the last few years, whatever we have delivered, if only we were as competitive as the rest of the world, we could have delivered them at this much cost, lesser cost to the world economy. In other words, it's also a pointer to how we are losing market share. Another major factor affecting India is the fact that many of our firms, industries are in the MSME sector, micro, small and medium enterprises, and they are not in a position to invest heavily in capital items. In other words, if value of items can be brought down only by very high level of investment in plant and machinery. This is a scale-based advantage, and we are not in a position to claim that in the international market because most of our production happens in the MSME sector, which means we have to rely very heavily only on supply chain efficiency for cost reduction. If you look at agricultural produce, the waste is estimated to be anywhere from 15 to 20% in the Indian context, which we can ill afford. You will also see that product and process innovations are not keeping pace with changing market needs because of the sluggishness in the entire supply chain. These are factors which force our hand to adopt the digital technologies as early and as prudently as possible to become competitive both in the local market as well as in the global markets. What technologies are we looking at? If you open the hood, underneath we can see the sensors, ICT, and Internet of Things, and industrial Internet of Things based technologies. All of them work with sensors being placed to observe the environment and pick up data from there, then feed it into an intelligent system where it can be processed and then subsequently fed again to some actuators which will activate the appropriate arms and legs of machinery. Identity management, network security, distributed networks are one set of technologies, all once again digital, which have become commonplace now. We started with robotics many years ago. These robots have also gained considerable capabilities, additional capabilities through machine vision and speech recognition technologies, and automation coupled with robotics is taking us much farther in this journey. Natural language processing capabilities are being added, and once this is done, this is going to be even more powerful in delivering the required efficiencies in supply chain. We started with the analytical techniques using OR and other models long ago. They gave rise to expert systems which helped us to describe an ongoing system, what was known as descriptive modeling. From there, we went to predictive modeling, and we are in a stage where we could even go to prescriptive modeling. In other words, description, meaning how does it function, predictive, meaning what will happen in future if the current situation is allowed to continue, and prescriptive is if we intervene in the system with different control mechanisms, what is likely to happen. In the process, we have also learned how to teach computers the way we observe, we learn, we infer, and many of these cognitive reasoning methodologies have been step by step built into the capabilities of the machine. So machine learning has come to play and has given birth to deep learning. And at a highest level, we can look forward to a much higher level of artificial intelligence technologies playing a key role. There are quite a few technologies on the horizon. They are at various stages of development and getting continuously debugged and introduced to the market stage by stage. One of them is what is called as 3D printing or additive manufacturing. We will take a look at this as we move forward. Another is wearable technologies. Third is mobility, GPS, and autonomous vehicles. And the last one is the blockchain. These four are currently in early stages of implementation, but the prediction or forecast is that within the next decade or two, they're all going to go mainstream and make a significant impact on world economy, along with impact on supply chains and the manufacturing activities. If we pry open to the next level, you can see some of these technologies, such as analytics, identity management, network and security, have all become core. In other words, whatever application we talk about, these are taken for granted. They will be there in some form or other. Then there are many other common technology components such as sensors, speech recognition, NLP, cloud computing, robotics, big data, deep learning, GPS, machine vision. These are the other common technology components that are fairly well developed, but still not yet at the maturity stage. They are in the growth stage. These technologies combine in different modes and fashions to give rise to what we can call the application technologies of autonomous vehicles, artificial intelligence, blockchain, IoT, etc. Now, every one of these, we can look at the use cases or instances of application in specific industry verticals. We will see some examples as we go along. But the net impact of all of that is what we consider as the performance of the supply chains as measured through the metrics: demand forecasting efficiency, order fulfillment, cost management, productivity and quality, safety, sustainability. These are the key metrics used in supply chains. And you can see each one of these technologies are already delivering substantial benefits with respect to these metrics that we have in mind. Wherever we have put a star, they are making an impact and in early stages, but it's only a matter of time before you see this complete matrix being filled up with more strong yes indicators. The cutting edge of all of these technologies in work, even as we speak today, happens to be in Japan, on the outskirts of Tokyo. It's about 2 to 3 hours away from Tokyo in a town called Oshino in Yamanashi Prefecture in Japan. Fanuc, which is a robotics manufacturer for the entire world, its global headquarters is located in this city, and it has a population of only 9,000 people. There are about 22 factories there, and all of them put together produce 7 times more robots than the number of people in the city every year. In other words, about 5,000 robots are produced in these factories every month. And each factory has at best only 4 human workers supervising work at any given time. These factories are complete light-out factories. Robots build themselves, inspect themselves, test themselves, and are ready to carry on as many of the cognitive activities that we do as possible. 90% accuracy level has been obtained, and men are utilized only at a supervisory role at this time. What technologies are used? Every one of them that we mentioned in the last few slides. They have all come together to create the factory of the future, which is totally automated. Let us look at artificial intelligence and machine learning and related technologies. The endeavor here is to teach the machine to see, observe, and infer just like we do. And where are these technologies used? In multiple situations, both in factories, offices, and elsewhere. In factory premises, we have long ago moved from breakdown maintenance to preventive maintenance. Now, the use of these technologies with sensors and algorithms that analyze the data in an intelligent fashion helps us to go even from preventive maintenance to predictive maintenance. How does it help? Preventive maintenance means that you are projecting a particular machinery to function for another, let us say, additional 3 weeks or 4 weeks, and the breakdown is expected to occur at that time. So you will plan a maintenance schedule accordingly. But on the contrary, the actual failure may occur even before those 3 weeks or much later. The predictive maintenance, on the other hand, calls for putting sensors on a continuous condition monitoring of the equipment and coming to know when the machinery is likely to fail just few hours in advance. In other words, the production stoppage can be initiated much, much closer to time with a high level of predictability. So the plant throughput is considerably higher. Another major use of this artificial intelligence and associated analytical methods is what is known as regenerative design. In other words, whatever design is coming out of a system is used to produce a prototype or release a product on a proof of concept basis, but you continue to keep in touch with the marketplace, with the product, observing its performance in the field, and that data is collected and fed back to the design system, which means the system responsible for design now has additional inputs about the usage parameters of the product, and hence it can improve upon its original design, and next batch of production can be even better. So that is where the technology has helped us to move with respect to production and design. The wearable technologies are quietly but strongly making a big impact. As many of us know, that wearable technology has resulted in watches are seen in intelligent smart watches. They are seen in smart wristbands. There are shirts, T-shirts, where embedded sensors help to pick up body and other related parameters and feed them to intelligent computers. As of today, as we talk today, iLens is available, which is a smart contact lens which can collect data about the performance of the eye and feed it to a system so that the wear and tear associated with the lens and its performance details are fed to the system to give any corrective action. In fact, the smart contact lens is nowadays embedded with a telephoto lens so that what you see as a real-time visual can also be captured and presented to you as a real motion picture kind of a scenario. Above all, the smart contact lens now is embedded with the capability for night vision. You can see the benefit of this for groups like defense personnel working in the war front or patients and children in hospitals. Many of them stand to gain considerably with the availability of wearable products from these technologies. We talked about 3D printing. 3D printing technology helps you to minimize the material waste, because as opposed to the conventional way of producing products where material is continuously being removed to give the product the shape it requires, on the other hand, the 3D printing technology adds material layer by layer, thereby adding only the exact amount of material required to produce any product. So the material wastage is completely eliminated. And in the process, we can also get into just-in-time production of items, because the 3D printing machines can be placed at the customer premises, and hence anytime, anywhere production is possible. These are ideal for low-cost prototype production and even very, very complex objects, but made of smaller size materials. The technology has advanced to a stage as of now to even printing body parts such as ears, and few other body parts are now getting printed using what is known as biomaterial in a 3D printing scenario. Let us not think these are far-fetched. Already we have 3D printed model home produced by Larsen and Toubro and kept for display near Kanchipuram in Chennai. It is a 700 square foot home built in 106 printing hours only. India aspires to produce 60 million homes almost a year, and what we need is a technology of this kind where the cost is reduced, construction is quicker, and you may have also read about the recent announcement by Government of India. The Prime Minister has initiated building about 1,000 model houses in 4 different states using similar technologies. It will go a long way to meet the aspirations of millions of citizens in India. The autonomous vehicle technology is being developed in a furious pace in the last decade. Sensors, processors, and actuators come together in a mobility setup to give the vehicle an autonomous capability, meaning driving itself by itself without the help of a driver. They can go from one designated place to another. This is a very disruptive technology, because once it comes into play, we can look at taxi services being available plenty without the need for any drivers there. Also, trucks in a convoy can carry tons of material from city to another in a much safer way. We can also look at the use of this technology in war fronts, in defense requirements. There are many, many places where it is too dangerous or hazardous for human beings to go. For example, in sewage pipelines, go inside, inspect, find out the defect, repair. All of that can be now done by robots which are capable of moving from place to place on their own. The use of this technology is endless. Warehouses, various other places, wherever we can talk about safety and better utilization of assets as the key objectives, autonomous vehicle technology has a role to play. And we are going to see more and more of this in play in the coming decades. Blockchain technology has made a foray in the last few years. This is an extraordinarily brilliant solution to a common problem that we have inherited over the last 200 years. This is where, in order to ensure a fair and equitable way of keeping track of transaction between any two parties, we had resorted to the double entry bookkeeping methods. In other words, if you and I do a transaction, I maintain a record of what is the transaction in my book of accounts, and you also maintain another set of entries in your book of accounts. So if there are multiple parties involved, everyone maintains a separate book of accounts, but in the process you will find there is a linkage between the transactions that I have and you have. So it also called for periodic reconciliation efforts to ensure that the data tallies between the two. If we have gone through multiple buying and selling transactions in a year, for which payments have occurred at different points of time, the reconciliation becomes a humongous issue. So the entire ERP system, whether it is meant for the manufacturing sector or the financial services sector, all of them have been focused only on reconciliation of digitally kept data. But that itself has constituted huge amount of work for every enterprise. With the blockchain technology, where a distributed ledger with irrefutable transactions is going to be maintained in every legal entity, with every legal entity, there is no need for any reconciliation at all. So all reconciliation functions will simply disappear as we move into this technology. All legal contracts, the asset records, transaction records, every one of them will move into this. Is India lagging behind? Definitely not. You may have read about Coffee Board already using blockchain technology to link 30,000 of its coffee producers with curing works, with traders and the end market customers. All of them have been brought together in a blockchain-based system so that coffee, as it is grown in one plantation, we now know how to trace it as it moves from the plantation to the factory to the marketplace and the end user. So complete tracing of food from the safety angle, from the selling angle, all of that is possible today. And the contracts that every two parties have are in a non-repudiable fashion maintained in the system. So the payments can be effected very quickly and the differences in financial details are going to be minimal. So this technology is also going to have a significant impact on supply chains. India has come a long way. Maruti factory near Delhi has numerous robots focused on improving its productivity, quality, and safety. Here is Akash Sinha, CEO of Omnipresent Robotech, a Delhi-based robotics company where his robots are utilized for inspection in industrial and defense settings. We have Schneider Electric, focused on smart factories and where the digital technology is utilized for preventive maintenance as well as energy conservation. Atlas Copco provides solutions for training skilled workers with the technology that it has. We have Indospace offering smart warehouses for safe and efficient storage and retrieval of items and accurate inventory counting. Status-aware technologies, meaning is the item cold, hot, does it have high moisture content, etc., can also be monitored, which is of very high value for perishable items, storage, and usage. So there are any number of such examples that we can look at in the Indian context where the digital technologies are pushed into play. But our discussion will not be complete without talking about application in the agricultural sector. As we know, the farmer needs a lot more help in terms of improving farm productivity as well as his own income. As of today, the average monthly income of a farming family is not more than 10,000 rupees. We already saw wastage in the system is almost 20%. The digital technology has been pushed into input selection, soil health monitoring, wealth advisory, crop management, and water management activities at the farm level. And the farmers' use of ICT technology and systems such as ENAM by Government of India and eChoupal by ITC, they have come to help the farmer with real-time data on product prices in various markets, helping the farmer to contact the end customer directly, eliminating middlemen in the process, and improving their own realization from the current level of 20% to 50%. Obviously, we can use the technologies to improve warehouse and refrigeration capabilities, transportation efficiency, and bring in considerable amount of price stability into this market. Given this background, one of the major concerns that has been raised is about elimination of jobs. Are these technologies taking away jobs and hence detrimental to the interest of the country? This has been a key query that has come about in multiple forums. Even though a McKinsey study done in 2017 has shown that over the next decade, about 800 million jobs will be affected worldwide, out of which half of them would call for retraining existing workers. The other half jobs would go away, vanish because of these technologies. But the McKinsey study also has given us the assurance that if we are going to lose 400 million jobs in the next decade, there will be equal number of jobs created because of the introduction of new technologies. Net, what it means is that considerable amount of turmoil, churn going to take place in the job markets. So India has to look at it with an India-specific lens and an India-specific model, which focuses a lot more on applying these technologies for services and distribution efficiency improvement, followed by product and factory applications. For example, we can talk about smart services, even though more than 50% of the national revenue comes from services, we still have not adopted the service level culture. Service level agreements have not become commonplace. Services need to be standardized, trained, accredited, and monitored. So there is tremendous opportunity to introduce digital technologies for service opportunity identification, accreditation, service certification, etc. Many services can be converted into digital transactions and digital records. And we have already seen things like Indian Railways announcing that no longer one needs to produce a paper printed ticket to board the train, that you can show the e-ticket in your mobile phone that is good enough, thereby saving millions of paper being printed unnecessarily, and considerable cost reduction. So digital transaction, digital records leading to digital delivery of services can benefit the country enormously. We have talked about government services. We are already seeing in the areas of health and education, particularly during the COVID period, how digitization has helped to keep the system running, and also the e-governance aspects, with government transferring many of the funds directly to end users. The unnecessary leakages in the system have been stopped, and Government of India has also introduced the GEM system, whereby all government procurements, public sector procurements of major items will go through a digital procurement channel. Once again, you can see the tremendous benefit the country stands to gain by the introduction of these technologies under the smart services category. We already saw the need for improving the logistics in every sector, including the agricultural sector, in moving goods from place to place, consignment consolidation or spot assembly, mixed mode delivery, eliminating non-value adding roles. All of them can contribute significantly to improving the cost effectiveness of our logistics services. On top of that, safety of vehicles, goods, and people is of paramount importance and consideration to us. Location-aware technologies, status-aware technologies, and selective use of autonomous vehicles in military applications or in war fronts or in dangerous zones. These are areas where even India can consider selective application of autonomous vehicles. So the logistics sector presents ample opportunity to cut distribution cost and waste in this country. Smart factories can lead to smart products can be created because every product now can be embedded with intelligent systems which can help to customer data, usage data, and fed back into the product to improve its design, improve its manufacturing, etc. So product standardization and componentization provide tremendous opportunities for improvement. Similarly, maintenance and usage. Field performance monitoring helps us to know what is happening to the product as it is getting used in the field. And on that basis, data can be collected and analyzed using AI techniques to look at the raw material composition, chemical mixing, and effect improvements on a continuous basis. So products becoming smarter means we are in a position to improve service level and product performance on a continuous basis. We can also look at factories becoming smarter in terms of material accounting, warehousing, shifting from made to stock to make to order, equipment condition monitoring, and all. Above all, the workstations in India can become smarter by feeding a lot more information about the assembly lines, component manufacturing setups, etc. So the worker at a given workstation is now equipped with higher order information to perform a better job. Continuous training of workers can also be done. Their skills can be developed on a continuing basis using these technologies. Better work scheduling can be effected. And above all, with the robots can be made safer to work along with human beings. And that technology is called cobotization. That is IoT plus human safety. This has a tremendous appeal in wherever chemicals are being manufactured, fertilizers, oil refineries, many such places, factories where human beings can be made to work safely along with the robots and other equipments. We have already seen the use of 3D printing in smart factory setups. All of this can be affected only if we are able to improve the skill sets of our workforce on a continuous basis. This is where we can use the skill set trifurcation model, which says always a set of people are needed to conceive and design the product, which means the skill sets required to be built in them is of a different order. While the product that is made has to be implemented in many customer premises because it has to be customized and linked to the environment that exists in a specific customer place, there are many people who need to be trained to implement and maintain the generic product at a specific customer environment. Then a large number of employees in the customer firm need to be once again trained to utilize these digitally driven systems to provide appropriate services to their customers. If we are talking about X number of people to be given these skill sets, we are talking an order of 10x for implementation and maintenance and 100x for providing services to customers. So here is a model which says on an ongoing basis, whether it is a product or service, how we can continue to develop skills in people, continue to build them, and improve the efficiency of the entire system. So in a very short period of time, we have covered vast ground to see how digital technology, known as bits and bytes, can be meaning much more than that to all of us. The digital technology components have already come into service, providing significant improvements in our standard of living, safety, cost efficiency, and other factors, and their impact, expected impact on an ongoing basis in future is even more impressive. However, I would like to conclude this discussion by going back to our definition of smart factories. Smartness in this context has to be defined not merely in terms of the machinery, equipment becoming intelligent enough to do what human beings do. They have to go far beyond that. The smartness comes because as human beings, we carry the responsibility to considerate to the environment, conserve natural resources, and care for other human beings. If equipment can also be endowed with these qualities for conservation, for care, for preservation, and hence ensure that we coexist in a natural order, man and machine. And if that level of capability is built into the system, we can define them as smart systems and smart factories. With that, I would like to conclude this presentation and open it up for question and answer sessions. Thank you.
Thank you, Dr. Balasubramanian, for your wonderful presentation covering various aspects of digital supply chain management and smart factory. In fact, the technologies what you have outlined are really mind-boggling. The way its application will be transforming the industry is really to be seen in India. Whereas in abroad, there has been instances where these technologies are being put into use. But we are stepping into the new era of adopting these technologies. In fact, some of the initiatives of the government of India, like Digital India and Make in India, they are trying very hard to see these technologies are getting implemented. And government of India is also investing huge amount of money in doing research and development in these technologies.
Very true, Mohan.
Yeah, in fact, you have given an excellent overview how these technologies are being utilized, and there are few questions we would like to ask. It may not be directly related to what has been covered, but still, it is going to be talking in terms of certain economics and also some issues related to these smart factories. Considering India is a large country and where the operations are not scaling up in many places. In fact, still, yeah, India is a country of small, medium, and micro enterprises. In fact, we believe in empowering every individual, and that way, when compared to industries abroad, our industries are in small scale, and these implementing this automation or the technologies, how easy or how difficult in
Uh,
Indian context?
Right. Now, this is where we have to understand the cost effectiveness of digital technologies. Uh, Many of these components are capital intensive and hence call for very high level of expenditure. However, it almost goes without saying that wherever capital intensive technologies are introduced, they also are likely to reduce the labor requirements to produce a given set of items. As opposed to this, India can look at any number of technologies where capital intensiveness is not a requirement. I, in fact, alluded to it in the presentation saying, given that we have a responsibility to nurture this MSME segment and also generate employment. In fact, a study has revealed that in India, we have to, given the demographic situation, we have to create almost 1 million jobs every month. 1 million new jobs every month. So we cannot adopt those technologies merely from the point of view of how high end is it and what would be the least cost production. In fact, it would be quite fine for India to accept a middle path whereby cost reduction takes place not to the maximum extent possible, but step by step without affecting the economic opportunities, employment opportunities for the nation. So MSMEs can look at such technologies and pick them appropriately. There are particularly many IoT applications where the sensors can be easily embedded and the data transmitted to a cell phone, which is easily affordable by many of the MSME sector, and certain level of data processing can be done within the mobile phones and fed back to the worker and managers in the MSME workshops to improve their own performance, their understanding of customer, product performance, etc. So we can choose a middle path and select many of those technologies within this digital world.
Is there any study has been done in terms of identifying which are the areas where India can implement these technologies, particularly considering aggregation model and scaling up will help in these areas?
There are plenty of studies which all have essentially pointed out that ICT, information and communication technology, can be leveraged far better in Indian environment so that multiplicity of market-based information and product performance information, produce information can be given to the farmer and to improve his realization from the sale price. Right now, if an item is sold for about 100 rupees per kilo, the realization for the farmer is only 20 rupees. So the technologies, meaning collection and use of this information being fed back to the farmer, can take him up to realize 50% instead of 20%. In fact, the ENAM project that I mentioned has already been initiated by government. Some 500 odd mandis, electronic mandis have been set up so that farmers can go and provide their output, produce, directly to these mandis instead of to the intermediaries. And once they go to the mandis, they will know what is the best price they can get, because it's an electronic system between that links the buyers and the sellers. And the farmers' goods are electronically weighed so that there is no duplicity in weight measurement, and farmer's account is immediately credited as he leaves the mandi premises. He doesn't have to wait for 15 days, 30 days to realize what is owed to him. So simple use of this ICT in this context, with a cell phone providing the farmer with current prices, which market gives him best sale, and helping him to conclude the deal through a non-paperless system, payment being effected through a electronic system. These simple things like this can be right away implemented in India and can be spread right across.
Okay. Yeah, but there seems to be some issues of political interference in many of these initiatives, particularly looking at the current agriculture doing strike and certain reforms, what is being planned. Particularly, trying to scale up the operations to introduce automation is the contract manufacturing, contract agriculture, right? Smart agriculture requires, see, when you want to use these technologies like drone and even IoT sensors and robotics in agriculture, you require some minimum scale. Instead of having 1 acre, you can't implement automation, right? So you need to have a larger area for devoted for agriculture, so that you will be able to utilize or implement the technologies in a cost-effective way. But the people who are the small farmers, they are going against, because they don't want to support this contract manufacturing. So these are all certain political interferences, which I think, we need to wait and see how these things will take shape.
Well, we don't have, history gives us a very good example. If you go back and see what level of agitation, non-acceptance existed for railway computerization 30 years ago in this country. This was one of the biggest benefits that has accrued to India by computerization of railway reservations. But I remember the first 3-4 years, there was so much agony, agitation against it. Same thing is true in the early 1980s.
Bank computerization.
Bank computerization, LIC computerization was introduced in the country. Today, everyone understands how the banking transactions have not only become smooth and more efficient and cost effective, but also considerably widespread in terms of bringing tremendous inclusivity in the citizenry.
Okay.
So history tells us that every major change is likely to encounter issues of this kind, because one set of stakeholders are going to be affected. But in the larger interest of the nation as a whole, we need to move forward.
Okay. What type of reskilling you suggest for people already employed to get into this smart manufacturing and smart factories?
Certainly, the skill set trifurcation model gives us an idea. If you are near the end customer, you are in the sales and marketing side, obviously you would like to pick up all those skills relating to customer interfacing. Much of the digital technology today is used in understanding market sentiments, feeling the customer pulse, improving your yield from existing customers rather than spending your effort on finding new customers. So all of these are technology tools are available today, and one can equip himself with that. On the contrary, if you're at the other end, design end, there are more and more of the artificial intelligence based tools coming out, helping us to understand the intricacies of product design. And so they have to pick up appropriate technologies and skills from there. There will be a very large number of population which will have the responsibility to take this and implement it in many firms' premises, because every firm is different in terms of the context in which it functions. They all have to have intermediate level skills. The model is applicable both for products and services. This is where even the education system, moving from monolithic 3 or 4 or 4-year degree courses to a ladder-based system of certification, diploma, then degree, and giving that growth opportunity is a wonderful way of doing this.
Yeah, lateral exits are possible depending on the level at which you want to.
Correct. So people can acquire a certification, go work for some years, earn enough money to support themselves, come back and go for the diploma to degree. So this becomes a continuous process, and even those with the degrees can be asked to seek recertification once in 5 years or 10 years because the technologies have changed. So there is a continuous learning opportunity here. The world hereafter is going to be one of continuous learning, lifelong, rather than you learn for the first 25 years and then work. No longer, that the world is going to change permanently into this mode.
So you have to be learning continuously. That is
continuous.
See, in terms of our educational system for engineering, basically, see this, right now we seem to be having compartmentalized education. Like, for example, core subject like mechanical engineering, electrical engineering, and computer science, where focus is more on programming and development of applications and things like that. But this subject of smart factories and Industry 4.0, popularly, the other popular name is Industry 4.0. It tries to sort of consolidate or interdisciplinary in nature, as you have mentioned. There are so many technologies are being used. So what is your suggestion in sort of improvising the engineering education in this area? Particularly the people coming out of engineering colleges, they are not a direct fit in any of the employment. In fact, many surveys, they point out there are a lot of employment, but the people are not employable. So what type of suggestion do you have in this regard?
Well, to start with, we certainly have to strengthen the industry-academia collaboration in this in multiple ways. Why it is very common abroad for a high school or a college student to go on internship every year to one company or other. We could very well introduce that system in this country in a very big way. Whether the student is in first year or second year, even at that time, they are very capable of being absorbed as interns, given insight into how the factory works, how the workplace is, and hence before he goes back to learn in a college environment, he already has an upper hand in terms of knowing whatever I have learned so far, how applicable is it? what kind of a change do I need to do? So the internship programs have to be tremendously strengthened in this country, opportunities to be created for students through the summer and winter vacations, number one. Number two is the faculty have to be given the opportunity for higher level of interaction. In fact, the interchange between academia and industry in terms of faculty going back and forth must be strongly encouraged. And I also see people like us who are alumni of good institutions, who have worked in industries at a stage in life, we talk about giving back to the society. I hope we come up with better mechanisms which extract the wisdom and capabilities of the alumni people and bring them back into academia, into the training programs everywhere, so that the issue about graduating students being non-employable vanishes completely.
Okay. Yeah, I think whatever you said is highly practical, but unfortunately, this is not happening. That is the only thing. Though we have been planning to some extent, these are being practiced, but we have to adopt it at a larger scale.
Yeah, they are happening.
Yes,
There's a considerable awareness everywhere.
Yes.
We are only still in the awareness stage, but action stage is delayed. We need
Yes.
to give a push for it.
Yes. And okay, there is one question relating to 3D printing. Basically, conventionally, the 3D printing has been using the plastics for many of the applications. Now, what type of material inputs are going to 3D printing? Are they really capable of taking all types of material which may be required for smart manufacturing and any different type of component?
Yeah. Actually, the 3D printing technology has advanced from plastics to single metals. There are many single metals which can be pulverized, and sprayed in the form. There are many metals which are now doable in this fashion. Where the technology has to move ahead is composites or hybrid metals.
Yeah,
That
smart
technology is still being perfected because metal to metal, the diffusion level, the heat, all of them are different. So to fuse them and convert them into a powdery state, to make it flow through and deposit and adherence properties, all of that are work in progress.
And also a lot of research is going on in metamaterials.
Yes.
I think that parallelly things are trying to get converging into taking to advantage.
And also, as we mentioned, the biomaterials,
Yes.
that is also a developing field.
Yes.
That by living organisms and their biomaterials are being modified, shaped using 3D printing technology for example, tissue engineering, a field where I have some involvement for the last 10 years. Nowadays, wherever there are burns-related wounds, burn warts, tissues from, earlier we were taking tissues from third parties and using them as implant material to help the burn patients. But now technology is available to take the what is known as autologous material, good skin from the patient himself or herself, and utilizing it in a lab environment to grow it to required dimensions and properties and use it as a replanting material. So 3D printing is coming into play for this.
Okay, there is a question relating to blockchain. Does blockchain address the non-repudiation?
Certainly, that is the most important benefit of blockchain, because if there are two transactions related. The second transaction will be added into the block with the first block, and they become two blocks in this blockchain. The second block will be added only when all the involved parties accept and agree
Consent.
this is a valid
Consent.
transaction.
Okay.
So this is where I mentioned about reconciliation. We allow two transactions to happen independently and later on get into a reconciliation exercise. This will go away completely because the second transaction has to be accepted by all the involved parties before it can be fused into the block.
Okay.
So that is the non-repudiation aspect.
Okay. How far our Indian auditors are conversant with blockchain technology? Will they accept this type of transactions?
I'm sure they will. In fact, if you see, there are many webinars and seminars conducted by the Institute of Chartered Accountants, cost accountants. Even within that community, there are many sessions on blockchain, and there are considerable debates taking place. They are obviously raising certain concerns about them, which are very legitimate. The blockchain technology also, as of today, is only in a proof of concept stage, not completely debugged. Okay. And associating it with some kind of a cryptocurrency has also given it a bad name to start with.
Yes.
Have not allowed us to see the basic benefits that can come out of the blockchain technology.
Real benefits are not understood properly.
Understood. So I think the chartered accountants are also aware of the potential benefits, but we need them to look at it from multiple angles: taxation angle, audit angle, fraud angle, and give us the assurance that once technology, we say it's ready, they are in a position to test it, debug it, and certify it for use. So in that sense, their role is very vital in the society.
Okay. Are there any issues relating to security in this entire operation of smart supply chain and smart factories, and how these security issues are addressed in the overall?
Yeah, well, this is a common problem for all digital technologies. Once we say digital, the events happen, transactions occur at a lightning speed. And information is stored in a digital medium, which means they're all open for any kind of fraud or deception or security breaches. This is a common issue with anything to do with digital or computerization. So the manner in which the security related technologies are developing, going from encryption standards being set higher and higher from time to time to better authentication, identification technologies, and certain audit controls and approval data, multiple layers of access rights to data, whether you have only a viewing right or you can modify it, or you can only add but not subtract, things of this type. All of them are going to help to improve the acceptability of digital technologies. But at the same time, we have to be cognizant of the fact that once we say digital, there is certain level of risk associated with it, just because the risk comes not from the technology, but people are using the technology.
That is true. Okay, when we talk about so many technologies, now there is a concept called digital twins are becoming popular. These digital twins, do they have any role in smart factories?
Very certainly they have a limited role, for the simple reason the digital twin technology is all about, let us say, factories working and real-time basis, the factory-related parameters are being noticed by concerned workers and managers. Let us say we feed all the data into its digital twin, and the digital twin will take that data and make a projection and say if every machinery in the plant continues to work in this fashion for the next 1 hour, 1 day, etc., which one of them will fail or where will the flow be impeded. It will make a projection and tell us that under current working conditions, if they continue, maybe in a day's time, in a week's time, these are the likely bottlenecks, problems to occur. And that information is given to us today, 1 week in advance, 1 day in advance. And so in mission critical applications, it is very important to use that and change the way we operate today, because we operate today assuming this is the best condition.
Okay.
So in that sense, digital
Yeah, more
twin
for
technology can
predictive,
be useful.
more for prediction and things like that. This will be useful.
Prediction in dire situations, where it
Right.
can lead to a dire situation.
Okay, so critical infrastructure management.
Yeah, a machinery failing means it will lead to a fire hazard, factory shutting down.
Okay, so sort of simulate the environment basically.
Environment.
Okay, thank you. And of course, you have outlined the implementation priorities, in terms of digital technology. Like the best thing will be for us to start with services and logistics, because our revenues are more in this area.
Correct.
But with the condition like, the China has been the leader in manufacturing, and with the relationship with the major countries, China and other countries, there is the relationship getting strained, and India seems to be having an advantage in this direction. So there is a possibility that we can become a major player in manufacturing. So where do you expect us to be in another 5 years in terms of product and smart manufacturing?
My own views are that Indian economy, being 85% a domestic economy, only 15% dependence on exports, is a boon in disguise, actually, because there is so much to be done within this country in terms of making products available and affordable to people of this country. These technologies can be introduced right away, particularly in services and logistics, so that the lot of the Indian populace improves in terms of their standard of living, in terms of their employment potential, etc. And in the process, naturally, as our economy becomes stronger, we can slowly shift priority towards products and factories. And we will, because it is not going to happen in one big step. We don't have the investment potential to do that. And that kind of investment may help us to capture some share in the international market, but we are far better in taking a measured step and growing to that stature rather than trying to jump steps and focus on exports.
So which means
for example, you may know
which
that
means
in
our
spite of our 20 years of efforts, various efforts, the exports share of Indian economy has not budged from that 15 to 16% over 20 years.
okay. So
That is because we still have so much more to do within the country.
okay. So I think your explanation reinforces our decision of not joining regional cooperation, which has been promoted by Asian countries. So
we need regional cooperation, but that need not be the end-all objective.
Okay. Thank you. Okay, thank you very much, Dr. Bala, for your wonderful presentation and also the Q&A session. And in fact, this topic is such a interesting topic, and obviously, 1 hour, 15 minutes, the time given is not adequate, and every technology can be talked for hours together. So possibly, we would like to have some sort of a longer session sometime later, I'm sure that we can take your support in this direction.
Certainly, there are many experts in the field who
Okay.
probably know much more than I do in specific technologies. We
Yes.
can rope them in.
Yeah, we can
And,
open and then make it a longer session. Maybe for each and every technology, we can allocate one hour, minimum 1 hour, so that people can give more inputs on these technologies.
Yes,
So
sir.
now, before we close, I would like to request Dr. Sakthivel, our chairman, IEEE Computer Society, to propose the formal vote of thanks. Dr.
Thank you,
Sakthivel.
sir. Thank you for the opportunity.
To all of you, I wish you very happy New Year 2020-21 to all the participants. So this webinar is the first webinar in the year 2021 by the Computer Society of India, ACM and IEEE Computer Society. So on behalf of Computer Society of India Chennai chapter, ACM Chennai Professional chapter and IEEE Computer Society Madras chapter, I would like to thank today's resource person, Dr. Parasuram Balasubramanian, founder and CEO, Teamwork Analytics Private Limited, Bangalore, for his excellent and informative lecture on supply chain management and smart factory strategies. I hope all the participants have benefited with this lecture. Thank you very much, sir. I would like to thank Mr. H.R. Mohan, Chairman, ACM Chennai Professional Chapter, Mr. P.V. Subramanian, Chairman, CSI Chennai Chapter, and Dr. Ahila, Managing Committee Member, CSI Chennai Chapter, for their dedicated arrangements in organizing this webinar. I would like to thank all the participants who have participated through the virtual environment like Google Meet and YouTube. So without their participation, the lecture would not be a successful one. So I thank all of you, all of the participants. So once again, I thank all of them. Thank you very much.
Thank you.
Mohan, sir.
Okay, thank you, Dr. Sakthivel, and once again, our sincere thanks to Dr. Bala. Before we formally close the session today, I have a few announcements regarding our forthcoming program. On 8th, that is on Friday, we are going to have a session on ML evolution of a new era DevOps. So it will be on Friday, not on Saturday. We have been having the sessions regularly on Saturday, but on Friday, the change of day. And then on 23rd of January, open data for sustainable. And on 30th, we'll be having a program on experiential artificial intelligence for social. So we have already sent circular regarding these programs. Please do register and attend and get benefited. So with this, we will close our today's session. Thank you very much for your participation. Once again, our thanks to Dr. Bala. Good night.
Thanks, Dr. Bala.
Sir, lock out பண்ணிட்டு try run connect பண்ணலாமாங்க சார்?
Message
Try and